A pretty common thing that we all do as programmers is we take some kind of a list of data in the form of an array, and we need to transform it into something else. A really powerful way to do that in JavaScript is by using the reduce function, which is built into all arrays. Now, in order to use reduce, you need two things. The first thing you need is a reducer, and the second thing you need is the initial value of the accumulator. Here's how that works. Let's say we have a list of numbers and we want to add them all up. This is the classic example of reduce, right? Our reducer looks like this. It takes two arguments. The first argument is called the accumulator. The second argument is the item in the array that you're going to be integrating into the accumulator. And what you're going to do is you're going to return a new accumulator. So because we're summing up an array, we're going to return the previous accumulator. This is what got returned the last time this function was called. And we're just going to add that to the current item. So if the accumulator here is always the previously returned accumulator value, then the very first time this runs, we need to provide some sort of a specific value so that it knows what to start with, since it never worked, never fired before. So the second thing we need is the initial value. And for now, let's just call that 0. Now, our array so far is empty, but let's run with this. I want to show you that it doesn't crap out or anything if you call it on an empty array. When you say var total equals data.reduce, reducer, initial value, if your array is empty, that just means that this function is never actually going to fire, right? Because this calls once for every item in the array. If there's 0 items in the array, this is going to fire 0 times. What's going to happen is your initial value is just what's going to get immediately returned. So let's prove that that works the way I'm telling you. Console.log, the sum is you can see here the sum is 0. And that's not just a random 0, that is exactly the initial value. If we pass in 10 instead of 0, the sum is 10, right? Let's set this back to 0 for now. And let's add an item to our array up here. Let's add the number, I don't know, let's add the number 15. So now the length of our array is no longer 0. The length of our array is now 1, which means that this is going to fire once. The initial value is 0. That's the initial value of the accumulator, the one time this runs. And the only item in this array is the number 15. So this is going to fire once, and it's going to return 0 plus 15, right? So the total we should expect to see is 15, and we do. Now, let's add a couple more values here. Let's add 15 plus 3 plus 20. Let's step through how this is going to work. The first time it fires, the accumulator value is 0, and the item is 15. It returns 15. The second time it fires, the accumulator value is 15, because that's what got returned the last time. The item is 3, so the total value here is 18. Finally, it's going to fire a third time, so the accumulator value is 18, and the item value is 20, and so that's going to return 38. Now, the way this always works, the reduce expression here, this whole thing is an expression. That means it evaluates to a specific value. Array.reduce always evaluates to the final value of the accumulator. So this whole thing is just going to be 38. All right, so let's say you just went to your local front-end programming meetup and you took a vote. You went to everybody there and you asked them to name their favorite front-end programming JavaScript framework. So the votes start pouring in. You got some votes for Angular, you got some React, another Angular, it's the Ember dude in the corner, it's another React, and you know, there's always one, right? No, I don't need no framework. I love spaghetti. And what we want to do now that we have this list of votes is we want to turn this into an object that gives us the number of votes for each framework that was named, right? Well, you should think to yourself, I've got an array and I want to turn that array into an object. Hey, this is a job for reduce. So let's remember how reduce works, right? We've got our accumulator, and that accumulator is going to be an object. So let's set our initial value for that accumulator, and it's just an empty object. And we've got our reducer, and that's going to take the accumulator, let's call it the tally, and it's going to get each of these votes one after the other. And remember the way this works is tally here is whatever got returned the last time this reducer was run, except on the very first item where the tally is the initial value. And then vote is just going to be each of these items in a row. So here's how we're going to do this. We're going to say if the tally does not have a key with the same name as that vote, then we're going to create one, and we're going to set its value equal to 1. However, if the tally already has a value for that particular vote, we're just going to increment it. And then, because this is a reducer, it's very important that you remember to return your accumulator, right? So the result of our informal poll is going to be votes.reduce. It's going to take our reducer, and it's going to take our initial value. Now, let's just step through and make sure we understand exactly what's going on here. So we've got our votes. We're going to reduce it using this reducer. This reducer is going to take the accumulator, and it's going to take the first item in the array. So the vote here is going to be Angular, and the tally is going to be this empty object. It's going to say, hey, does tally.angular exist? No? Great. Tally.angular now equals 1. Return tally. It's going to get called again. Vote is Angular again, and tally is the return value from the previous iteration. So it's an object with one key, Angular, whose value is 1. Now when we get to our logic, we're going to see it does exist, so we're going to increment that. Now we're returning an object whose key is Angular and whose value is 2. We get to the third item here, React. Well, vote is React, tally is this list of Angular is 2. So we're going to create a new key, and we're going to say tally.react equals 1. So when we return that, it's an object. It's got 2 keys, Angular, whose value is 2, and React, whose value is 1. And so on and so forth. We're going to step through every item here, and we're going to integrate each of those items one at a time into our running tally. Because this is reduced, this whole thing evaluates to the value that gets returned from the very last call of the reduce function. And so when we run this, we see we had 3 votes for Angular, 4 votes for React, 1 vote for Ember, and 1 vote for no framework. I'd like to talk a little bit about some different kinds of reduce operations that are pretty commonly used. In fact, some of them are so common and so everyday that they don't even use the reduce function. There are other ways to implement them, but I'd like you to still be thinking about these as reductions, because what they do is they take an array and they transform it into something else. So the most common one of these is, or one of the most common, is let's say you've got some array and you need to transform it into another array with the same size, it's got the same number of items, but some sort of transformation has happened to each item in that array. So for instance, why don't we take our data array here and we're going to reduce it into another array where every value is doubled, right? So you can say var doubled equals data.reduce, and the initial value for our accumulator is going to be a new array. And all we're going to do is say accumulator.push value times 2. Then we need to make sure that we return the accumulator. So if we say console.log my doubled data, we'll see that we've indeed turned every one of these values into its double. So if you're paying attention, you might know that there's another name for this operation. This is called a map. We've mapped this array into this array, and JavaScript lets you do this particular kind of reduction just by using a different function. We can say var double mapped equals data.map function item return item times 2. When we run this, we'll see that we get the same thing. Another very common kind of array reduction is one where you start with an array that has a bunch of values, and you need to reduce this array into a shorter array which only contains some subset of those values. So in this case, let's reduce this array into a smaller array which only contains the even numbers. Just like when we were implementing map by using reduce, we're going to pass in an empty array as our accumulator value. But now, instead of just taking every value and pushing it into our accumulator, we're going to do a little check here. We're going to say if value mod 2 equals 0, in other words, if the value is divisible by 2, then accumulator.push value. Return the accumulator. So console.log evens is going to spit out 2, 4, and 6. Now, if you're following along at home, you know that the name for this operation is actually filtering. And just like mapping above, JavaScript gives you a way, like just natively on the array object, to filter. So we can say var even filtered equals data2.filter function item, and we just say return item mod 2 equals 0. Right? And so if we log even filtered out, we'll see that that worked the same way. Now, I know what some of you are going to be saying right away. You're going to be saying, Mick, why on earth would I use this reduce function with all of these moving parts when I could just use a filter function, or when I could just use a map function? You might go on to say, look, it's even better because filter and map and all of these various array operators, not only do they take a simpler function, but you can compose them. So if you wanted to take our data set, right, and you wanted to filter to only return the even numbers, and then you wanted to double those numbers, you could do that very elegantly. You could do something like this. Right? First you filter. And then you just chain map right on top of that. Right? So if we console.log filter mapped, we get 8, 4, and 12. And you know, you're totally right. That is exactly the right way to think about this. If you have these tools that work like this, you should be using that. I still want you to be thinking in terms of reduction. I still want you to realize that what you've really done is reduced this array into another array. But keeping your code simple and concise and readable is really important, and I encourage that. But here's something that you might not have thought of. This is going to work fine, right? If you're running this on an array of 6 numbers here, do it this way, absolutely. But what if you have slightly more information, right? What if you have a big array? Let's create 1 million items in this array, right? And what if you wanted to perform the same kind of operation here, right? Let's, you guys know this cool trick where you can say console.time, and then we can do this same operation. We can say filter mapped big data. This is big data.filter. And then when we're done, we say console.timeEnd big data. And we're not actually, we don't want to, log out 1 million items into the console here, but we are going to log out how long it takes this thing to run. Okay? And okay, that's not bad. 76 milliseconds, right? But look at this. We have the same logic, right? But we're going to use the reduce function. And we're going to say if value mod 2 equals 0, then accumulator.push value times 2. Return accumulator. We're going to start that off with an empty array. And now we're going to say console.time end big data reduce. Wow, look at that. This one took 79 milliseconds, this one took 54. Why is that? Well, that's because when you're composing your map and your filter, first the filter is going to iterate through 1 million items, and it's going to return 500,000 items. Then your map needs to be applied to each of those 500,000 items. Contrast that to the reduce approach, where we're filtering and mapping all in one step. We only need to iterate over those million items once, and then we're done. So I'm not saying that you should always be doing this, but I am saying that for complex chains, like especially if you're doing things like filter this and then map to that and then like sort this and da-da-da, right? If you're dealing with a lot of information, then it can be very helpful to be aware of the way reduce can give you a huge performance boost by allowing you to merge all these operations together so you're not constantly iterating over the same data set. So we know that it's possible to reduce an array into another value by writing a reduce function. The reduce function has a signature that looks like this. It takes an accumulator and it takes a value and it returns some integration of that accumulator and that value to act as a new accumulator. So if we have some data that looks like this, we can reduce that data into a sum, for instance, by using this reduce function, right? Okay, so those numbers add up to 21. But what if we wanted, instead of just merely adding these up, what if we wanted to compute the mean? Now, in order to do that, we would need to take the sum, and then we would need to divide the sum by the number of items in that array, right? So it's easy enough to just say, reduce into the sum and then divide it by the length of the array. Let's add one more number in there just to make it not be quite so clean. Look, that works, right? But we haven't actually reduced this array into the mean. What we've done is we've reduced it into the sum, and then we've computed the mean. But as good functional programmers, right, we want to think in terms of like a pure one-shot way to transform our input data into the thing we really want. This should leave almost a little bit of code smell, right? We've reduced it into a sum, and now we're bringing something else to bear onto that sum. Is there a better way to do this? Well, the answer is yes, and the way we do that in JavaScript is by taking advantage of the fact that there's actually a couple other supported arguments into the reducer function. The first of those arguments is the index. So this is the index within the parent array of the value that is currently being evaluated. And the last one is the array itself. So what does this let us do? This lets us say, look, let's compute our intermediary value for our accumulator. And if this is the very last item, right, if this is the last time this is being fired, then we're going to know that that's the case because index is going to be equal to array.length minus 1, right? So if index equals array.length minus 1, instead of merely returning the intermediary value the way we do when we sum it up, we're going to return intermediary value divided by array.length. Otherwise, if this is not the very last time this fires, go ahead and just return the intermediary value directly, right? So you can see when this runs, it's going to run here, the accumulator is going to be 1, then the accumulator is going to be 3, then it's going to be 6, then it's going to be 9, then it's going to be 13, right? We're going to add this up until it gets to the very last step. Now in this instance, We have an array whose length is 8, right? So the very last time it fires, value is going to be 1. The accumulator is going to be 1 plus 2 plus 3 plus 3. It's 13, 18, 21. The index is going to be 7, right? Because it's the last item in our length 8 array with the 0 index. And the array is the array itself. So what's going to happen is that 1 is going to be added to our accumulator to give us our total of 22. This then is going to evaluate to true. So instead of returning the sum directly, we're going to go ahead and we're going to compute the mean right here inside of our reducer. So the big difference here, right, this is going to get us the exact same value. But now, instead of reducing the array into a sum and then computing the mean, we've gone ahead and we've directly reduced the array into a mean. And this is all one pure function. If you're writing unit tests, and you're writing unit tests, right? You can test this. You can pass in an accumulator and a value and some index and some array. And you can write tests to make sure that this behaves the way you would expect when you pass in, for instance, an array of length 1 and whatever, right? So given that it's a pure function, this is a rule that tells you how to take some array of numbers and reduce it into a mean. You know how JavaScript has a bunch of these curiously endearing little features, like if you say console.log number1 equals string1, right? What's it going to say? It's going to say true because it's trying to help you. So you have to go out of your way to make sure you use the triple equals in order to get JavaScript to acknowledge that these are not actually the same thing. Well, there's something similar when you're reducing arrays. Let's say we have an array of numbers, right? Textbook reduce example here, and we want to add these numbers up. So we know the way this works. We know we're going to have a function called a reducer. It's going to take our accumulator, it's going to take our value, and it's going to return the accumulator plus the value. And we know that if we say var sum equals data.reduce with this reducer, then that's going to add those up. But I've made a mistake here. Do you see what it is? I need to give it the initial value for the accumulator, and I didn't. And so you might expect this to fail. But actually, it's going to work just fine. Well, wait a second. How did that happen? I thought the accumulator is always what got passed in as the return value from the previous time the reducer was called. And so the very first time it runs, when the value is 1, this accumulator should be undefined, right? Well, in the JavaScript implementation of reduce, they've got this handy little feature where if you don't pass in an initial value, it just assumes that the first item in your array is your initial value. And this works like exactly for one scenario, which is when you're trying to add up a list of numbers, right? If you're trying to, I don't know, tally up votes or something, right? Like how many votes were cast for each of these values. And you want to do something like this, where if accumulator has a value for that key, accumulator value equals accumulator value plus 1. Otherwise, accumulator value equals 1. And then you just return the accumulator. The way you normally do something like this is you pass in that empty object, right? So when we run this, we can see we had 2 votes for each of these things. So what happens if we leave this out in this case? Weird. So the accumulator was just vote 1, right? Because when we didn't specify an initial value, it assumed that this is our initial value. And strings are primitives, right? They can't have properties, and so this always resolves to false. And so what's going to happen is that initial value is just going to get returned every time. So bugs like this can happen. They're incredibly hard to understand or figure out what the hell's happening, right? It's not like it's throwing an exception. It's not like it's returning undefined, right? It's returning a value. It's just, where the hell did that come from, right? Another common mistake that you'll see is if you forget to return the accumulator. You do your logic, but you don't actually, let's not be making two mistakes at once here. You've got all your logic, everything is good, but you forgot to return the accumulator, and now it's saying the accumulator value is undefined? Like what do you mean the accumulator is undefined? I set this in here. Well, this is actually the second time it runs. Because the first time it ran, it never returned a new accumulator. Accumulator became null the second time this ran, and you're going to get that kind of an error. So, two takeaways here. Number one, always pass in an initial value for your accumulator. Never rely on the fact that it'll automatically work when you're summing numbers, because the bugs you're going to find are really quite magnificent. And number two, always double check and make sure that you're actually returning the accumulator. Let's talk about a couple of patterns for reduction that you might not necessarily immediately think, oh, that's a place I should use reduce. A really common one is called flatten. Let's say you have an array of arrays, right? So maybe you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's just like an accident of the way your code is structured that all of these values are stored into all these different arrays, right? Really, you just care about these values. You really wish, instead of an array of 3 arrays, you just had an array of 9 numbers, right? Well, great news. We can use reduce to flatten this array into a single array, right? Flatten is what you call it when you take a list of lists of some thing and you return just a single list of that thing, right? So that's going to work like this. Right? Take your accumulator, take your value, and we're going to merge all of this stuff into a single new array. And, you know, there's a bunch of ways you could accomplish this. All we're really going to do is we're just going to say return accumulator.concat value. And now, if we log this out, you'll see that we have a single list of all those values. Now, some of you might be saying, okay, that's well and good. You've got this little contrived example here of a list of values inside of a list, right? So we've got nested lists. In the real world, it rarely gets this simple, right? What this is actually going to be is some giant list of domain objects, and you're going to need to transform this and pull this out and go through all these steps. And you know, you can't take some bunch of really complex objects and just reduce that down to an array of just the things you care about, right? Like that kind of thing only works in examples in tutorial videos. How could you do something like that with more complex data? Well, I'd like to introduce you to my next pattern here. Instead of flattening a list of lists, what we're going to do is take a list of complex objects. In this case, it's a list of movies, Christopher Nolan's Batman movies. And what we're going to do is we're going to reduce this list of objects into a single list of the stars that appeared in these movies. And we want to make sure, among other things, that we only include each star once. So we don't want to see Christian Bale showing up 3 times. So how can we do this? How can we do this with a single reduce operation? Well, this kind of operation has a special name. This is called a flatmap. And if that sounds familiar, it might be because at your local meetup, you might have heard some functional programmers talking about monads and flat maps, and you know, the rest of us have no idea what they're talking about, right? Well, until today, because I'm going to tell you, of course, that a flat map is actually just a type of reduce operation. Just like map is a reduce, just like filter is a reduce, a flat map takes a list of values here, where those values are potentially complex objects, and it turns each of those values into an array somehow, right? In this case, what we're going to do is we're going to step through, and we're going to, for each of these movies, we're just going to pull out the cast. Then it concatenates those arrays together with the flatten operation. And what you have in the end is a list of values that were extracted through some compound operation from a list of more complex values. So the naive way to do this, right, would be to say var stars equals input.reduce accumulator value. Our initial accumulator state is going to be an empty array, and like I said, the naive way to do this would just be to say return accumulator.concat value.cast. But this doesn't satisfy one of our constraints, right? If we say console.log stars, okay, there's all our stars, but Christian Bale, Christian Bale, Christian Bale, that's a lot of Christian Bale. So can we do this better? Of course we can, because this is a reduce operation. This isn't some, it's not like a map where we are constrained in terms of what we can return. We've got a lot of power. We've got a lot of flexibility. So we can do something like this. We can say value.cast.forEach function star. We can say if act.index of star is greater than -1, then, let's invert that. So if the accumulator does not have an instance of that star, if that star is not yet in the accumulator, let's say act.push star. Then return the accumulator. And bam, there you go. We've been able to reduce this list of movies through a flat map into a list of movie stars. So there's one more reduce pattern that I'd like to show you. This is not one that I think I've ever had occasion to use, but I'm sure somebody out there can, get a lot of mileage out of this for exactly the right use case. And so it's, it's a tool worth having in your toolbox. As you know, if you reduce over a set of values, here, let's create some dummy data here. I'm going to make 5 into a string, and you'll see why in a second. So you reduce over this data. Let's add these up. You're going to go, and the function that you're providing is going to be called for each of these values one at a time in order from left to right. Okay? And so the index, the first time it's called, is going to be 0, and then 1, and then 2, and then 3, and then 4. Right? And I just want to log that out so you can see. And this is just going to be a regular sum operation. We're going to return accumulator plus value. So what is this going to resolve to? Anybody want to take a guess? If you guessed 15, you're wrong. Resolve to 105, because in JavaScript, a number plus a string is actually a string concatenation operation. So our accumulator starts at 0, we add 1, then we add 2 to that, then we add 3 to that, then we add 4 to that, and we're at 10. We add the string 5 to 10, and that gives us 105. And as you can see, our index started at 0, then 1, then 2, then 3, then 4. But maybe it's really important to you. Maybe this isn't a bug. Maybe you have this string 5, and you really need to start with this. And you want to reduce this array so that it starts here and then works its way down, right? When you do a for loop, you can count down instead of counting up. You want to be able to do that for reduce, right? Is there some way to do that? Sure. Instead of calling array.reduce, call array.reduceRight. Now you can see we're counting down from index 4 to 3 to 2 to 1 to 0. And our final output is what happens when you append the string 0 to the string 5 to the string 4 to the string 3 to the string 1 or 2 to 1. So when you think about reducing arrays in programming, you know that it means to take some list of data and programmatically transform that data into some other value. And when you learn about functional programming, one of the core concepts that jumps out at you is that, well, hey, if I have first-class functions in my programming language, like JavaScript does, then really functions are just data. And if you put these two ideas together, something kind of interesting happens. But before we dig too deeply into that, I'd like to set the stage here. I'd like to talk about the kind of operation we're going to be doing and what would be a naive way to do that. So let's say we have a bunch of simple mathematical functions. We're going to be able to increment and decrement a value. And we're going to be able to double and have a value. Now, let's say that for whatever reason, we have this requirement that we're going to get some input value, and we need to increment that value, then we need to double that value, and then we need to decrement that value. Okay? So one way that we could do that would be to say var initial value equals 1. Var incremented value equals increment initial value. Var doubled value equals double incremented value. And var final value equals decrement doubled value. So if we say console.log final value, we see that the final outcome here is 3. But I hope that this is setting off a whole bunch of alarm bells for you, right? You wouldn't actually want to do it this way. This has, you're initializing all these different variables. You're making your code much more complex to read, right? And you're introducing mistakes. What if I, accidentally decremented my initial value because I totally just boneheadedly forgot that I'm changing my variables or whatever, right? This is not the way to do this. So you think, okay, I'm a good programmer. I'm going to write a single function which captures this behavior and doesn't pollute my code space and my scope with all these other variables. So instead of doing it this way, I'm too smart to use all of these small functions up there, right? I'm going to write a function called transform, and it takes an input and it returns, let's see, input plus 1 times 2 minus 1. And I'm going to say var final value equals transform initial value. Right? Same answer. This is a little bit better, but I would encourage you to consider in this highly contrived example, but also in real examples that you will encounter in your real day-to-day lives, I would encourage you to consider another approach, which is don't take all of this complex behavior and stick it all in one line that just, has to work, and don't think too hard about it later. If it's not working, just, cross your fingers and hope for the best. Let's be good functional programmers here, and let's use functional composition, which means that instead of writing a function like this, we're going to create what's known as a pipeline. Now, you might hear this term thrown around because pipelines are really popular right now. They're useful in things like stream computing. They're useful when you're doing big data analysis. All the reactive stuff just loves this. A pipeline is a term for a series of functions that get applied to some initial value in order to return some final value. And this pipeline can be invoked as just one single function, so you don't have all these intermediary values littering up your code base. So pipelines work great at large scale, Hadoop, big data, whatever, but they work just as well in simple little JavaScript stuff. And in our little example here, you're going to see exactly what that means. So the behavior we want to capture is we want to increment a value, then we want to double that, and then we want to decrement that. And so our pipeline is just defined by listing the 3 functions in the order that we want to use them. Now we can say var final value equals pipeline.reduce. We're going to get to reduce eventually, right? Which takes the accumulator and the function and takes the initial value. Now remember how reduce works. The accumulator is whatever got returned the last time this function ran, and fn in this case, this is the value in our array. So when we call this, fn the first time is going to be increment, and the accumulator is going to be the initial value. So we're going to increment the initial value, which is 1. That should give us 2. So then the next time this is called, the accumulator is going to be equal to 2. And the function, we want to apply the double function, right? So that's going to return 4. And then we're going to pass for in as the accumulator and decrement as the function. And in order to make this work, this is super simple. Watch. We just want to say return an application of the function to the accumulator. Now, when we run this, we see that it gives us exactly what we want. Now, this is way cool. This is so much cooler than you might think, right? Because this is totally composed. We can look at this pipeline right here, and what do we notice about it? This is an array. That means that this array can be programmatically generated. We can have some other piece of our code base somewhere, maybe, for this particular use case, because it did a bunch of lookups, the pipeline is increment, then double, then decrement. But maybe if some flag somewhere else in our system is set, we want to increment it 3 times, then double it, then increment it, and have it, right? Well, okay, imagine if we were doing this in the other way, right? Where we had all of this custom logic and this big complex nested mathematical expression. You couldn't just easily mutate that. Further, you couldn't look at it and see it as just this set of very simple functions. You can read this. You know you're going to increment something 3 times, you're going to double it, increment it 2 more times, and then have it, right? When we run this, see the answer is 5 instead of 3. This should be reminiscent, if you're familiar with Unix pipes. This is something a little bit like, it's almost like we just did this, right? And that's pretty awesome, right? Because the outcome, we don't care about anything that happens in the middle. What we care about is the final output of that process. Now, there's also, some people like to think about this in the opposite direction, right? So I just would like to take one last second here and remind you that reduce right is also a function, in which case you're going to have the value first, then increment, double, increment. Reduce right means rather than starting at the first value, start at the last value and work backwards. So if we reduce this to the right, then we get that. Today I'd like to show you how to use array.reduce in order to deal with data that is maybe not quite as clean as we'd always like it to be. And to celebrate the new Star Wars movie, I thought I'd use some Star Wars characters as my sample data here. No spoilers here for anything new. So here's what we've got. We've got 3 characters, Luke, Han, and Anakin. We've got their name, we've got whether they're a Jedi, and then we have their parents. And all we care about with their parents is whether that parent was a Jedi. So for Luke, his father was a Jedi, his mother was not. For Han, both of his parents, we assume, are not Jedi. But we get to Anakin and we have a problem, right? Because Anakin doesn't have a father, if we listen to the original trilogy and we let his mother stick to her story. So how do we make an informed decision about this? If we try to write some pipeline that looks at character.parents.father.jedi to find out if that parent was a Jedi, we're going to get an undefined exception, right? So let's write that real quick so you can see what I mean. We can say characters.forEach. Let's just say console.log character.name father was a Jedi. And then we can say character.parents.father.jedi. Right? So let's run this. We can see that it worked. Luke Skywalker's father was a Jedi, true. Han Solo's father was a Jedi, false. And now, oh no, we got some kind of a problem here. Why? Because we're trying to read the Jedi property of the father object, of the parents object of Anakin. And as you can see, there's no father defined, and so this fails. So how many times have you actually seen this, right? Like this happens so often when you're programming. You've got to do these null checks if you're trying to read down this path. And sometimes that's fine, right? Sometimes you don't care. Sometimes if you could have some rule that says, look, if father doesn't exist, assume false, right? That's a perfectly valid way to approach this. We don't want to invalidate our entire strategies just because our data is polluted in this one instance. But is there some way we can write code that will not crap out while getting us the behavior we care about. And it turns out that there is, and it turns out that our old friend array.reduce is going to help us with this. Here's what this looks like. Let's write a function called father was Jedi, and it takes a character. Okay. The trick here is that we need to come up with the path that we're going to follow down through the character. So that's going to be parents, or let's make this a string, parents.father.jedi. And we're going to say path.split. So we're splitting the path on the period. We're going to return this. Path.split.reduce function object field. And the return, or the initial value here, is the character. So this is a little bit of an unusual formulation. We're not used to seeing things work quite like this. This is not a standard reduction for a lot of us. So let's step through how this is going to work. We know, or we should know, that when you split a string, you provide the character, and what it's going to do is take this single string and turn it into an array of strings where this character goes away, right? So every time it sees this, it's going to close that string, open a new string. So if I say path.split period, it's going to return an array where the first item is parents, the second item is father, and the third item is Jedi. So we're going to do this. We're going to say if the accumulator object exists, return object field. Otherwise, just go ahead and return, return false. So we've got our array of parents, father, and Jedi, and we're reducing it. And so what's going to happen? The first time we call this, the object is the character that we've passed in. And the field is going to be parents. So the character does exist. So we're going to return character.parents. That's what this is doing, right? So for each of our three values here, that's going to be just fine, right? So now the object, the second time it's called, is the parents object. And the field is going to be father. Now, that's going to return, in this case, it's going to return this object. In this case, it's going to return this object. And in this case, it's going to return undefined, right? We don't know. There is no father. So the last time this runs with Anakin here, we're going to look at OBJ object here is going to be undefined. So it's just going to return false. It's not going to try to read undefined.jedi. But for Luke and Han, it's going to go ahead and read father.jedi and return that. So then all we have to do here is, instead of doing this hard-coded lookup, we just say father was Jedi character. When we run this, we see that Luke's father was a Jedi, Han Solo's father was not a Jedi, and Anakin Skywalker's father was not a Jedi. So I don't always recommend using this all the time, right? A lot of times, if your data doesn't contain some field, then sort of coercing it to fit this mold by using a reduction like this is actually a band-aid on a larger problem, which is that you are trying to use your data in a way that it doesn't, was never intended to be used. So if you are going to do this, make sure you understand why your data is malformed. Make sure you understand what exactly is going on there, and that you're not going to be violating some core assumption of your domain by, coming up with some default value to escape these undefined checks. But, there are definitely those times when this is just a super useful trick to know.